Today we're looking at Glencoe Accelerated Math Lesson 9-7 on solving systems of equations algebraically. So, for those of you that don't like graphing, this lesson is going to be a little bit better for you because there is no graphing in this lesson. Okay? Sometimes we have two equations and they're not written in slope-intercept form. And it may be easier at that point to solve by what we call substitution. And that means that we're going to literally put one of the equations inside the other equation to solve for one of our variables. And then we will substitute that solution and to find the value of our other variable. Okay? So what this means is that we're going to have to keep our work very, very organized. We have to be able to see easily what two equations we start with. We have to be able to see what we do to find each variable. Alright, and I'm going to do an old-fashioned zoom in. There we go. Alright. Let's say that we have, like we do in example 1, y equals x plus 2 and y equals 5. So, the first thing I'm going to do is write out the two equations that I'm given. Y equals x plus 2. And y equals 5. Alright? So, substitution this time is really easy because I can literally replace this y with the number 5 to solve for x. So we're going to do that. 5 equals x plus 2. What do I do to solve for x in this situation? Okay, let's say that I'm going to have to show my work. I'm going to have to subtract by 2. So then 3 is equal to x. How do I write my solution then? Because I still write my solution as an ordered pair. What's my x value?
3.
My x value is 3. What's my y value? 5. So my solution is a 0.35. Questions?
That was easy.
What? We're good with that one?
Yes.
Okay. So, let's think about this one as a degree of difficulty of like a 1. Let's increase our degree of difficulty just a little bit. Let's say that we had example 2. So, if we have example 2, we'll do that one in a different color. Can someone please read for me, what are the two equations that I have in example 2? Nobody can tell me what they are? Go ahead.
Y minus 3x equals negative 13. And 4x plus 5, y equals 11.
Okay, did I copy these appropriately? Fantastic. So, the first thing I'm going to do is look at where can I easily substitute. So my first equation, I have a single y by itself. But it's not written in a y equals format. That's okay. What I'm going to do is relocate that negative 3x. So I have y equals something, and then I can put the rest of that in for my y here. Okay? So, I'm going to start with y minus 3x equals negative 13. I'm going to add 3x to both sides. So I have y equals 3x plus negative 13. Okay? We're good with that part. Here's where we do that substitution. Okay? In example 1, we substituted a single number in for y. This time we're going to substitute in the equation. So I'm going to take 4x plus 5y equals 11. 4x plus 5. We know that 5y means 5 times y. So we're going to multiply by what y is equal to, 3x plus negative 13, and say that that equals 11. Questions at this point?
Wait.
Questions at this point? Yes, sir.
Okay. I got it a little bit. Where'd you get the 4x plus 5?
Y equals 11?
Mm-hmm.
Okay, so we have both of those equations that were given in our problem.
Okay. Yeah.
So we are told to solve the system of equations algebraically with the equations y minus 3x equals negative 13 and 4x plus 5y equals 11.
Oh.
Okay.
I see it. Wait, I have to
All right.
see it.
So then we did this part, which said we relocated our negative 3x so that we could figure out what y was equal to. And then we put that solution for y, and we substituted that for y in my second equation. Okay? Alright, we're good so far? We took what y was equal to, but instead of it being a number, it was an expression. We substituted the expression in. Alright? What do I do first to solve this equation?
We get x by itself.
Okay, so that is our goal, to get x by itself. How do I do that first? Go ahead.
Don't you have to get the like terms?
Like terms together?
Yeah.
Absolutely. Can I combine them at this point in time?
No.
Not yet. What do I have to do first?
Simplify by multiplying 5 times 3x and by 5, or adding 5 times negative 13.
Okay. What is it called when I take the 5 and I multiply by the 3x and by the negative 13?
Distributive property.
Very good. So the first thing I'm going to do is distribute the 5. That gives me 4x plus what's 5 times 3?
5
15.
times 15.
15. 15 what?
15x.
X.
Plus 5 times negative 13 is?
Negative 66.
Negative 65. Good. And that equals 11. Alright, so the first thing I did there was distribute. What do I do next?
Like terms.
I combine my like terms. What are my like terms that I can combine at this point?
15x and 4x.
Okay, what is 4x plus 15x?
19x.
19x. Plus negative 65 equals 11. Now what am I going to do?
How are you going to
Add 9. No. Add
divide
65 each side.
minus 11?
Hold on. I'm hearing a whole bunch of things. Let's raise hands so I know what's going on where. Yes, sir?
Add 65.
Very good. I'm going to add 65 to both sides. Why am I adding and not subtracting? What? Because it's negative. To eliminate a negative 65, I have to add a positive 65. That creates that zero pair. Okay? 19x plus negative 65 plus 65 is 19x.
Equals
11 plus 65 is
76. Crap.
76. It's okay. Now what do I do? Divide each side by 19. What is 76 divided by 19?
4.
4. All right. X equals 4. So we have the first part of our solution. We have the x value. X equals 4. Second part's easier. Ready? Okay. Because my y is already by itself in my first equation, I'm going to substitute this x into my first equation to solve for y. Ready? Okay. I'm going to move to the side. Don't get lost. Woo. Okay. Y minus 3 times 4 equals negative 13. What do I do? Yes, sir.
3 times 4.
And what is 3 times 4?
12.
So y minus 12 equals negative 13. Then what do I do?
Subtract or add 12 to both sides.
And then I add 12. That leaves me with y equals what?
It leaves you with negative 1.
Very good. Y equals negative 1. What is my ordered pair? What?
4 negative
4 negative 1. $99 times out of 100. Finding our first coordinate, finding that first part is going to be the hardest. Because you have to do a lot of manipulating your expression in your equation first. Okay? Once you get one of your values, the other one's going to be easy. Because you're substituting a number, not an expression. Okay? What questions do we have? What questions do we have? Yes, ma'am.
Will there be problems where x is on the other side of the equal sign?
Yeah, we could. The x and the y variable can be on whatever side. What we are going to do is try to get one of those variables by itself. In this instance, we tried to get the y by itself because there was no coefficient there. It was just y, so that made it a little bit easier. Wherever that variable is that we got by itself, that's where we're going to replace, that's where we're going to substitute. Okay? So let me ask you this. Could I have gotten these both into slope-intercept form and then graphed?
Yes. Yeah.
Would it produce the same solution?
Yes.
Yeah. We could. Are we going to do that today?
No.
No. Very good, because today we're solving algebraically. All right? What?
Thank the Lord.
All right. I'm sorry?
I am not messing with those graphs.
I think this is one of the first groups that I've seen that didn't like the graphing part. A lot of people that I know, they prefer the graph over the algebra. Okay.
The graph was hard.
Not long giving instruction. So, that's okay. That's why there's more than one way to do it. Okay? Let's look at another example. Are we ready? Can I erase because I've run out of space?
Yes.
Yes, I can erase?
No.
All right.
Go ahead.
The next okay, the next one that we're going to look at is example 3. Alrighty. In example 3, again, they gave us a lower. So the last problem I I'd say that was a degree of difficulty of about a 4. I would call this one more like a 2. Okay?
So why do we go up? I mean, why do we go up and we're going down?
Because of our solution.
The 2 letter what?
5. Okay? And so these are, my degree of difficulty, it's out of 5. The solution is why we did it in that order. Y equals x plus 5. And then we have 2y minus 2x equals 10. Alright. So, do I have to do any manipulating to get an equation where a variable is by itself? No. So, what can I automatically substitute here?
No.
Right, I can substitute for y. What am I going to put in place of y? What am I substituting that y value with? X plus 5. Okay? What do I have to do first?
Bless you. 2x.
Right. And what is it called when we get 2x plus 10?
Distributive.
Distributing. Minus 2x equals 10. Then what am I going to do? What?
Commutative property.
Very good. I'm going to use the commutative property to do what goal am I trying to do?
Get your variables next to each other.
Get my variables next to each other. 2x minus 2x plus 10 equals 10. What is the combination of 2x and negative 2x? 0. What am I left with? Equals? Okay. Is 10 equals 10, is that a true statement?
Yes. Yeah.
Yes, it is. So guys, guess how many solutions there are?
10.
0.
Infinite. Okay.
I said 10 million, gazillion, billions.
So, in that situation, there are infinite solutions. So, we know that if we can get an x value and if we can get a y value, and those are independent numbers, we have one solution. If we get to a point where the numbers, where we have just numbers and they're equal to each other, then there are infinite solutions. Could a situation exist where there was no solution?
Yes.
Yes. What would that look like in our work, where there was no solution?
No writing.
0 equals 0, but does 0 equal 0?
0 equals 1.
Hold on. Pause. If we ended up with 0 equals 0, is that a true statement?
No. Yes.
Does
Yes.
0 equal 0?
Yes.
Yeah, that's a true statement. So how many solutions would there be?
Infinite.
Infinite. This could be 10, this could be negative 142, this could be a half.
This could be negative.
As long as the value is the same, that's saying that we have infinite solutions. So what situation would come up where there would be no solution?
Where it was an incorrect statement, like 0 equals 1.
Very good. If this statement wasn't true, like if we had 7 equaling 22, does 7 equal 22?
No.
No. No. That's not okay. So in that situation, then there would be no solution. Okay? Does everybody understand that? Alright. In the problems that we do today, you will have only one solution. Alright, I picked problems where there is only one solution today, okay? Everybody got that? Okay. Would you like to see another example before we move on today?
No, we're good.
Yeah.
Oh my God.
Okay.
Somebody else
Hey. I'm going to go ahead and end the video here, and then we'll do another example. Thank you so much.